You guys gotta focus. Whoa.
Are you tired of your boring, unscriptable maps remaining just that? Boring, unscriptable maps? What's the point of beautiful doors if you can't even open them? Lamps that cannot be turned on or off?
Drinks that cannot be served, and taps that do not release the Lord's sweet, delicious liquor.
No matter how cool your diner is, nobody's gonna like it or rate it if you can't even turn the lights on. So, how do we fix this conundrum? We have a comment suggestion here. Who's our hero for the day? I'm probably gonna butcher this, but Lynx TSE commented, maybe instead of a click door, a proximity prompt door. With an animation or something. Thanks for replying. Smiley face. Maybe a proximity prompt door or an animation for the door. Maybe keep it a series, like how to make an interactable shelf or something cool. Smiley face. So special thanks to Lynx TSE. Appreciate the suggestion. That's what we're going to do today. I have here a collection of assets. We're going to script these assets today using the all-powerful
Proximity prompt.
Each of these objects has a prompt inside, and they've all been configured and named properly. The way I configured them is if you were to open up, say, this door, for instance, all of these have two folders, an interaction folder and a model folder. I'll go through each of them as we script them, showing you how I separated these, but basically the interaction folder just has parts that need to be handled by script. The model is everything else that the script doesn't need to mess with. Let's pick the easiest asset in this chain, so it's going to be easy for me, the doorbell. Now, what I did for the doorbell is we have interactions and model. The model in here has this little yellow button, but the interaction part has the actual board that it's attached to. Ooh, camera too fast. The board that it's attached to is actually where all of our sound effects and our proximity prompt are located. The sound effect's just right here, sitting inside the object. The sound effect is going to play from the object it's inside of. For the proximity prompt, I inserted an attachment into the part. The attachment is automatically placed into the center of the model, and then inside of this attachment is the proximity prompt itself. This is all you need to configure. The action text I set to ring. That's what it tells people they can do. It's enabled and it's clickable. This is the gamepad key code. 1 per button, basically meaning you're not going to have multiple prompts on the screen at the same time. 1 prompt per key, which in this case is the E key. I personally like having a little bit of hold duration. I feel like that adds a little bit of patience, but also experience to prompts. Rather than just a quick E-tap, the hold duration really lets you feel that you activated it. Max activation distance is basically how far you're allowed to be before it shows up. They can only be 10 studs away. If they're any farther, it disappears. And then the object text here is doorbell. I have it set to require line of sight, meaning if I turn my character around, I can't see it. But if I go back here and I've got a door in between, I'm not going to be able to see the proximity prompt. Versus if it doesn't require line of sight, it can make it to where there can be a wall in between and I'll still see the proximity prompt so long as I'm in the regional vicinity. So that's the basics on proximity prompts, very simple. How do we go about scripting these though? Well, we could just slap a script inside of it, but that would be too much repeated code. Imagine having to put the same script in every single doorbell in your map, every single door, every single window. And now, if you want to make a change, you have to go update all of those scripts. All of the scripts also use their own individual amount of RAM, or memory, so it'll end up slowing your game down too. So what's an easy way to fix this problem? Well, the best thing we can do is simply use tags. Let me show you what I mean. Tags are a feature that Roblox added. If we go into the properties of the doorbell model, you can see there's a tag section. Tags and attributes. Attributes let you make custom properties for the object. Tags allow you to define custom behavior for this object. Let me show you. The concept in programming, specifically object-oriented programming, is scripting simply behavior. Rather than having a specific script here for the doorbell called a doorbell script, we're instead classifying this object as a doorbell. Therefore, if it is a doorbell, it should have the functionality that comes along with the doorbell. So let's give it a tag. Push the plus button here. If a tag doesn't exist and you type it and hit enter, it will create a tag. I'm going to call this doorbell. This is now a new tag I just made called doorbell. And let's script our doorbell. So now that we've applied a tag, how do we structure the code? Well, check this out. Let's get a script in server script service. And I'm going to call this furniture. Now what we can do is if we grab something from CollectionService, so local CollectionService, get service, CollectionService. CollectionService is that it has a built-in function we can call that fetches all the tags. So it grabs all the tags that have been created. Let me get our doorbell. It gets all the tags that have been created. So doorbell, and I think I have a few more like closet and whatever this data test is. And then we can use another function from CollectionService which gets all the instances attached to this tag. So fetch all the tags, loop through all the tags, and fetch all the instances. So once we hit the tag doorbell, it gets us all the instances of doorbells. Workspace.interactables.doorbell. So it can get us all these models that have this tag on it. So that way, if we ever want to make a doorbell, all we got to do is make sure that the model's configured properly, the proximity prompt and an SFX, and then we can just add a doorbell tag to it. And now we've got a loop that'll get us all of those models. Now, we can do that and get all the models, but how do we code all of those doorbells? Because here's the thing, usually you slap a script in it, or at least that's how a lot of people on YouTube teach. You slap a script in it, and you say script.parent.proximity prompt, untriggered, yada yada, do this code. Well, we don't need to do that. We can simply use a single function to control our doorbell without actually needing to have multiple connections of code. All we have to do is change the way we think. Let me show you. Let's rewire the way that we think and instead write generic functions that don't specify what it's changing. So they don't need to go to workspace.interactables.doorbell to change doorbell. Instead, we'll just pass it in as an argument into the function, and it'll be able to modify and change the doorbell. To get workspace.interactables.doorbell, remember, we're going to loop through all the tags and loop through all the instances with the tag attached. So that gets us the data. We just need to write the logic now to process the data. Let's start with getting all of the modules prepared. We're going to use module scripts for this. Now, a module script, very, very simple. It's basically a script, but instead of running when the game starts, you have to turn it on. Now, when you turn on a module script, it runs the code, it creates a table, and it returns a table. So it's basically the module script is the entire script is a table. So we can simply name this module script doorbell, and this can hold all of our doorbell functions. Local doorbell functions equals return doorbell functions. Now, we're basically using object-oriented programming in principle. In reality, if you want to use object-oriented programming specifically in your game project, like I do, I don't do this format. Instead of having a table of functions and passing the doorbell around as a parameter, that's actually called data-oriented programming. To use object-oriented programming, you use metatables, but that's for another tutorial. It's a very complicated subject. Gets a little computer sciencey, so we'll tackle that later. This is much easier for newer developers to understand, so I'm going to start you guys off with this, but the principle still applies. We're trying to use one function or one set of functions in a module script instead of just, copying and pasting the functions for every single doorbell that we have. Let's just use one set of logic and just give the function the doorbell that we're trying to modify. So this creates a module. We make a table, which is going to be a dictionary. If you guys aren't familiar with dictionaries, this is a great time to go watch a few tutorials on it. This requires an understanding of tables to be able to get. So this is a dictionary. This is going to hold all our functions. We're going to return the dictionary. And so over here, if we want to access those functions, we just say local doorbell functions equals require. This is the function that turns on module scripts. And then we need to show it where the module script is. Script dot doorbell. This line of code is going to turn on this script. It's going to run through here. If I throw a print right here, it's going to print when this line is read. And this doorbell functions becomes this table right here that we're making. So this is a very efficient way to allow us to basically write code that can be used by other scripts, which is perfect for our furniture. Now all we got to do is for each of these furniture pieces, apply a tag, lamp, door, doorbell, window, fan. We apply a tag and then just code the tags in here. We create a module script with the tag name, and that becomes the behavior for that object. Let's start by writing our code to actually get our tags. I'm going to wrap this in a do. This is for garbage collection purposes, future tutorial, local function, get tags. This function is going to collect all of our tags and loop through them and turn the instances into objects. Get tags. This is how we're going to start our chain. Do get tags, and this will start our little code. Let's get our tags. Local tags equals CollectionService get tags. See, we can call get tags, or we can call get all tags, returns an array of all the tags in the experience. So this is now an array of all the tags in our experience. Let's loop through those. For underscore, we don't need the number because we're just going to go through all of them. Tag in I pairs because it's an array. Tags do. So this is going to loop through all the tags in our experience. Now, once we've got a tag, we need to loop through all the instances that have this tag on it. There's another function that returns an array of all the models that have this tag applied. To do that, we're going to create a function, local function. We'll call this create classes. A class is an object with behavior attached to it. So we'll call create classes tag. So this is going to loop through all the tags, and then it's going to pass the tag into this function. This function is going to take the tag, and it's going to loop through the tag by getting all the instances. So local instances equals CollectionService get tagged returns an array of instances in the game with a given tag or models. This gets us an array of all the tags. This takes the tag and gets us an array of all the instances that have that tag applied. So now we get to go through all the instances with the tag applied. Let's do that. For underscore instance in I-pairs, it's an array. Instances do. So now we've got a loop that goes through all the instances. So first it's going to be doorbell. This is going to get all the doorbells in our game, and it's going to loop through all the doorbells. Instance is going to be the model. Now, let's do another local function. Local function apply behavior. This is going to take a tag, takes a tag and an instance. And it's going to take the tag, use the tag to find our module script, our behavior, and then apply that behavior onto the instance. So tag instance. Down here, all we have to say is apply behavior, tag instance. There we go. So we got 2 loops that go through all our tags in the game, get all the instances attached to each tag in the game, and apply behavior to each tag in the game. This only needs to happen at the start. When this is going on, hopefully our player is going to be on a loading screen. So let's apply the behavior. First, let's check if there's a module script with that tag name. You notice I've got a tag down here. This is a plugin that makes it, called data, test ID, whatever. We don't have a module script called this. So if we just try to fetch a module script with this name, it's going to error. So first, let's make sure local module equals script, find first child, tag, if module, if not module, if the module does not exist, then return. If it doesn't exist, or not module is a module script. So this makes sure that the module is a thing. It's true. If it's true and it's a thing, it's a child of this, meaning it's an instance. So let's make sure that instance is a module script. If these two are good, cool. We'll go down to the code through here. If not, return. We end the function. So on line 12, let's use our deductive skills. We know that module is a thing. It's a module script as well. It exists. Tag is the tag that we're applying. Modules are behavior. Instance is the object or model that we're trying to apply the behavior to. So what would probably be a good idea is if we change the name of this to behavior. Now, we need to turn the module script on. So we can simply say behavior equals require behavior. So by the time we hit this line of code, behavior hasn't been set, so behavior is still our module script. Require, it returns our activated module script as a table of functions, and now behavior assumes that value. That's why this works. So now we just need to say behavior.new instance. Behavior knows what tag it is, so all it needs to know is simply the instance we're applying it to. Any arguments or settings, we could use properties or attributes on the model itself. Let's go in and script our doorbell. Doorbell functions. Doorbell functions.new equals function. Now we know doorbell is a doorbell model, and it's in our .new function. First, let's get our proximity prompt. Proximity prompt. Great function we can use is doorbell find first child, which is a proximity prompt. Now, the reason I'm using find first child, which is a proximity prompt, is because this has a setting. Set it to true, recursive. If it's recursive, if we throw a true down here, then it doesn't just look for a child, it'll look for a descendant, which is a proximity prompt. Meaning I can use it on this doorbell model, and it's going to look through the entire model, all their children, all its descendants, and find the first thing that's a proximity prompt and send it back up. So if we make sure our model has at least one proximity prompt, then we're good. I'm going to add a tag here. Not a tag, I'm going to add a reference. Basically, Roblox has typing that lets you say what it is so we can see the functions. This will make it easier for you guys while we're scripting. Now, when I say proximity prompt, I have access to all this stuff. We're looking for proximity prompt dot triggered. Connect function, enter. This right here is the player who triggered the prompt. We're not personally going to use this right now for a doorbell, but this would be a really good idea if you've got something that needs an interface. This is how you could get your hands on the player who used the proximity prompt and actually give them the GUI. Let's do another find first child, which is A, and look for our sound effect. We'll do SFX, sound effect equals doorbell, find first child, which is A. Let's get our spelling here. Sound part. Nope, that's parent. We're looking for a sound. That's the class name. Sound. Add recursive. Now we can say proximity prompt dot triggered connect function SFX play. And this will play on the server our doorbell sound effect. Now, real quick, I ran a quick test and realized our code didn't work because I forgot to pass in the tag here when we say get tagged. It's actually looking for the tag that we're trying to get. So we'll call get tagged, and then from here we can test. No errors, that's what we like to see. Why is our sound not playing? Okay, after debugging, I realized we're using a string called tag and not the actual tag variable. That was a dumb mistake. Okay, now our proximity prompt is created. Now we've got a functioning doorbell. Great, happy. So now there's a doorbell that works for our house. Let's see if we can tackle a door next. It's going to be a really long video. We'll do a door, and then next week we'll finish these since we got the back end done.
Has your Roblox game had too much non-script? Has your Roblox game had not enough players and too much time added? Fix this problem now and get big ka-chings by learning to script the easy way. Tutorials are cool, but they're slow. Take the fast way out. The basics of Roblox Luau. Make the money that you need tonight.
Full in-depth Luau scripting course.
The order which you should learn and how to learn teaches you everything from start to finish about script. $1, can I get a $2, $3, $4, $5? Bingo, sold to the fat man in the back. The scripting course teaches you everything that you need to know to make your own Roblox game. No more tutorials. Mine are cool, the rest are gay. Don't watch them. You can find out more information in the description. Read my sales page. I will convert you.
Ooh, you will buy the scripting course. Ooh.
Do it or I'll sneak into your house at 3 a.m. in a furry outfit. I'll make you walk me like a dog.
Okay, so let's move on to a door now. Let's script this. We'll do the others when we're done. Next video, I'm going to make another part. We'll do these 3 later. For now, though, let's do an animated door. The way I have this structured is the door is currently unanchored except for this one hinge part. This invisible hinge part is the shape of the door in the corner. It's anchored, and it's the primary part of the model. The reason we set it to the primary part is this dictates how the model moves. So you see we're rotating the hinge, and it's actually rotating the door on the hinge. That's because we went into the model, and we set the primary part to this hinge piece right here. Now, all the other pieces of the door are unanchored, but they have a weld constraint. This weld constraint is welding the object to the hinge. So every piece of this door is welded to this hinge, and it does not have anchored set to true. They're all unanchored, so it can freely move around. That way, the entire model obeys the door. We're going to use that later by only rotating the door open and closed, and the entire model will actually follow. So we have open and close sound effects. We have our proximity prompt. This is old. We just need the prompt. Here's the settings I have on it. Very similar to the light switch. Let's code it. Let's start by going into the door and creating a door tag. Create tag door. We now have a tag for this. And we're going to create some attributes. We're going to need 2 booleans, open, boolean, save. And we're going to need another one called moving. String, set it to a boolean, save. Moving is going to be how we tell if the door is currently moving. That way we don't cancel the animation if they try to open it while it's swinging. And open is how we tell if the door is open or closed. Let's create a module script in Furniture now called door, our new behavior, local door functions return door functions. Dot new equals function. Now remember, we're going to get our instance passed in, our door model, and let's start by getting our proximity prompt. Local proximity prompt equals door, find first child, which is a proximity prompt. And we need to throw a true over here so it's recursive. And let's get our sound effects too. So we're going to have two sound effects. Local sfx open equals door. I'm going to use my file structure here. I'm going to trust that all the doors in my game are properly configured. So door.interaction.handle.open sfx. Here's our open sound effect, and here's our close sound effect. Now what we're going to do is we're going to set our proximity prompt.triggered. Here's our triggered function. Now we need to make sure the door is not moving. Change open, animate the door. So let's start with this first one. Let's manage the moving variable. To get the attribute of a door, we need to say local is moving equals door get attribute moving. This is going to return the Boolean moving from here. If it's true, end the function. That means it's in the middle of opening. So if is moving, then return. Now, if we make it to line 15, that means they want to open the door, and it's currently not moving. So let's set the door to moving. Door set attribute moving, the attribute name, and the value we want to set it to, which is true. Over here, we'll close the door, and then we'll stop the moving, and then we'll just write our variables in here. Now, because we're typing this, door set attribute moving true, we're going to need to do the same thing for open. Let's make this a lot simpler and just put this in a local function. Change attribute. Model, name, value. Model, set, attribute, name, value. So this grabs the model, sets the attribute name to the value. Let's do another one for get attribute. Model, name. Return model get attribute name. Now all we got to do is just say get attribute door moving. Over here, all we got to say is set attribute. Oh, I'm sorry, I said change. Let's do set. That's easier. Set attribute door moving true. This way we're not having to run this extra code, but it's a little faster and a little snappier. Let's do the same thing with our open and close. Local is open equals get attribute door open. So if the door is open, this will be true. If it's false, it'll be false. So we'll say set attribute door open not is open. Not is open is going to grab the opposite of what it currently is. If this is currently open, this will be false. If it's currently closed, this will be true. Super easy way to simply flip the attribute. So in between these two, let's call our animation function. Local function get tween, or we'll call it create tween. Create tween. Now over here, tween, or we can say animation equals create tween door dot primary part. This is the hinge, primary part of the door, the hinge that we're wanting to rotate. We'll create the tween and we'll pass along the hinge. All right, let's create a tween. How do we make a tween? First, we need tween service. Game, get service, tween service. This is the service that lets us make tweens. Tween is a fancy way of saying automated animation. We're going to need some settings for this animation. So we're going to make a constant. Constant is something that should never, ever, 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 ever be changed. This is a value that will be permanent. That's why we type it like this, all caps with an underscore to separate words. This tells us, the developer, and other developers, this value should not be changed. It also doesn't change. We'll say tweeninfo.new. Let's type our settings. How long do we want this tween to take? 0.5 seconds. What should be the easing style? enum.easingstyle.linear, a constant speed. Easing style is the style of animation. And then easing direction modifies the animation if you so choose. Linear, you can't modify it. So linear is just a constant motion. One of the ones, quad for instance, is faster at the start and slower at the end. But we'll stick with linear for now. So let's create a goal table. Now what a goal table does is a goal table takes the property of the object you're wanting to change. It needs to be typed exactly the same. Position, orientation, primary part. Then it takes the value of what you want it to become. We want to change the C-frame of our hinge. To do that, we say C-frame equals hinge.cframe times, and we're going to need to create an offset value, times offset. Now, when you multiply two C-frames together, it simply combines them. Our offset is going to dictate whether the door is going to open or close. Let's pass a variable if we want the door open or closed, and let's set our offsets. We'll say if open, then close the door, else means it's closed, open the door. So we'll say offset equals cframe.angles, angles is for rotation, -90, 0, -90. I forgot we want to modify our doors Y. And then over here's to open it, or sorry, to close it, so we'll use a positive. No, positive opens, negative closes. We might have to tweak these a little bit when we're done, and that's okay. These are easy to change. So here's our offset. Here's the open rotation. Here's the close rotation. We base it off of the variable up here. We set this variable. We're supposed to set it here. We'll do is open. So we do the opposite of whatever this is. Then let's return a new tween. Tween service create hinge. This is what we're wanting to tween. The info and the goal table. It's a property table of how we want to change the properties. This will create our animation for us. And our animation is dynamic. It's going to change the rotation based on if it's open or closed. Now what we need to do is play the animation, play, animation.completed, wait. This plays the animation. This pauses the script until the animation is done. So this will pause the script until the animation is completed. Right before we pause, let's figure out what sound effect we want to play. If is open, then else. If our door is open, play the close sound effect. If it is closed, play the open sound effect. Let's give this a shot, shall we? Hopefully I didn't make any mistakes. We'll find out. I made a mistake right here. I'm sorry. So when you're typing your tween info, comma, you can't have a comma on the last one because it's arguments to a function. There's an open and close, and it's got this nice spiffy animation. We can't mess with it while it's moving, and we can easily modify the sound effect. So if you've got a steel door or a different type of door, you can simply change the sound effect that's hanging out in the model to adjust what this is. So this is a doorbell, a door, and we also covered how you would go about making the framework or the script that actually turns these into scriptable objects. But now all you got to do is when you build a door, make sure that it's structured properly. You've got an interaction folder that's got stuff set up how it should and it's welded. And then instead of slapping a script in there, all you got to do is add a tag and add the attributes. And bingo, this suddenly starts to work. It's scripted. Same with the doorbell. Next part in this series, we're going to cover lamps. We're going to do a sliding glass window. And we're going to do a ceiling fan that's going to have a light that you can turn on and off. For this one, we'll do 2 prompts. We'll do a prompt for the fan to turn on and off, and we'll do a prompt for the light to turn on and off. Once we get these and a couple of others I have back there set up, I'll get a little house model, and we'll fill it with these. I'll show you guys what it looks like to put these in a model and put them to use. So if you have any questions, or if you have any other recommendations for content, hit me in the comments. I'd love to hear your thoughts. If you had any problems with this that didn't quite make sense, let me know. I can offer some clarification. Hopefully this helps.
Wait, don't go. I have a favor to ask.